Hi all, I'm Luis Barbosa for Quantum Group. So let me start with our material. So today we are talking about data visualization. We used a very nice library called Altair that it's available for Python, for instance. So as environment, you can use something as simple as Google Colab. So simple Google Drive. You can create just the opening material here. Don't we're gonna use any Slack, any slides, any backup slides. But yeah, so simple Google Drive. Let's create a collab, and then we're gonna use an initial data set, something very simple. Let's use it. Let's import pandas to load the data frame, right? So would have something like this. Even a short data set here. So like a dozen students for different courses, their names, three different exams, one final grade, and that numerical grade converted to score. Let's see even less data. Let's only take first two rows. And for Altair, we're gonna import it. And if you're familiar, for instance, with tidyverse from R and ggplot2, it's quite similar. What they do is to use what in R they call kind of geometric. So the whole graphs and chart generation, it's based on the same pattern, the same structure. You only change two things. The geometry of what I want to show. If I want to show a bar chart, it's one geometry. What I call markings, or what are the markings you want to use. If it's a bar chart, a pie chart, a line chart, or histogram, whatever chart you want to use it. And then what what um, ggplot2 called aesthetics. They call it here encoding. So what, regardless how you call it, it's all the information that you want to inform as input definition of the graph. Also, what are the x values that going to be in x-axis, the y value is going to be in the y-axis, and so on. So that's pretty much it, right? There is one important thing that I'm going to highlight in a minute, which is if you compare, for instance, with regular visual library like Matplotlib or Seaborn, those kind of libraries that they require, they expect process data in order to present, in order to show. In Altair, similar to ggplot2, is that embedded within the data visualization mechanism, they have capabilities of consolidating and summarizing data. We're going to see that in a minute, right? But anyhow, the whole process, something like I can use reference for the ELT library that I just imported, rename it, and you say that you want to start based on what data set. Our data set, we call it DF, right? And yeah, the next step is to define what they call the marking. And again, ggplot call it the geometry. So if I want to here compare the students' grades, a very good graph to do comparisons is definitely a bar chart, right? So I can use here a marking of a bar chart, and then I can inform what ggplot calls aesthetics. They call it encoding. In the end, it's what are the input information for the graph. So the encoding here, I can say on the x-axis, I want the student column for my data frame, right? Student, and I compare each final grade for each student as a bar chart, student, and then on the y-axis, I want to show the numerical grade. That's pretty much it. Encode, it's encode, sorry, encode. Here it is. That's pretty much it. I can see each student and compare directly their grade. I see that like a couple of folks like Jose and Rachel, they are a little bit below the usual grades, and some other students like Silvio and so on, they are um, having very good grades, right? And then if I wanna not now compare student by student, but I wanna compare, for instance, the average grade by different course, usually what I would do is to do a summarization operation, which in Python, I could do something as simple as a group by. So I could do something like data frame, group by, course, and then I want to calculate the average, the mean on the column final grade, right? That's it. That's a summarization. So I have it here, the business administration course. It has a average grade of 6.6, economics 7.9, and law 7.2. I can even save this in into a variable. Let's call it I don't know, grade per course, and simply print this variable. Right here we have it. And then if I want to compare those values, again, I could use a bar chart, and I actually, every input data for Altair has come in a data frame form. So this summarized table here isn't supported input. You have to convert it in a proper data frame. The easiest way to do so would be something like grade per course. Now I can reset those index, reset index, and now our grade per course, instead of being a summarized table, it's an actual data frame, and the index that were the course name became a full-blown column, and now we have two columns, the course column and the average grade, the grade column, right? And with that information, very similar to what we did just before, here it is, something like this. I can even copy and paste. Now my data frame, it's called that grade per course, right? Instead of DF. In my x-axis, I wanted the course column. And yeah, and the y column going to be the grade. And it now can compare the average grades between different courses. If I'm the dean of the school or course dean, I can see that economics has a better average performance than the other couple of courses, and so on. The main point here with Altair is that this kind of pre-summarization is not really required. Similar to ggplot2 on R, in R, it can do this calculation internally. I could do something directly, not from the summarized table, but directly from the original data frame table or DF data frame. I could have asked for x-axis for the courses, and I could ask for it calculate before presenting the mean over the grade columns, right? So instead of simply showing information, can do some prior calculation, then show the information, right? And here it is, we have exactly the same results, with the advantage that I didn't have to do the group by, the summarization prior to the exhibition, right? And actually some of these internal calculation that they do, it's implicit. Actually, if I haven't meant or explicit said that I wanted the mean, if I said that I want just a grade, as it has multiple grades for each student of different courses, in order to present the chart, it's implicit that it has to do some summarization. The default summarization for him, it's actually the mean. So it calculates the mean automatically and show it like this. You can use it. To be honest, I prefer to be more explicit and make sure that I'm aware of what I'm presenting. But anyhow, in case if you're confident, you know what you're doing, no problem on stating like this. But I guess the main point is you don't have to do something like this, right? A group by, then reset index and stuff like that. Prepare summarize data frame. It can do summarization on the fly. So Altair has multiple markings, right? Bar charts definitely very used, but we're not limited to it. We have multiple things. Area charts, circle charts, line plots, scatter plots or point graphs, tags, and so many others. We're going to see a bunch of them today. Then let's try a pie chart. A pie chart they call arc, and similar to what you used here, the bar chart for comparison purpose. A pie chart, it's very useful to do proportions. You have an idea of 100%, a pie chart very useful. Again, let me show a little summarization here. It's not required, as I said, just to have an idea what kind of business rule I'm trying to analyze here, or business logic. I want to, instead of calculating the average grade by course, I want to, again, still group by course, but now I want to count how many students, and keep in mind that to have a student column that has each student name, student, and I can analyze the proportion, right? In total, I have very little people, not so many students, I have like a dozen, but you can see like only 2 of them are for economics and other 5 for economics, administration, and law, right? And if you want to compare this proportion using a pie chart, I can do something like this. Again, it's quite similar. So we using the library, I can create a chart object with the data source that interests me, the original data frame here, DF, and I can choose whatever geometry or marking. Now I want to use what they call arc, and the aesthetics, the encoding, I can input the encode that I want to use here. For the pie chart, you can have this input, what they call theta. That's going to be a counting, so I can count the student's name, and I can use as different colors for different slices of the pie, the name of the course. And here we have it, right? I can compare now, like I don't know, 15% of the students for economics, and about 40 something for business administration and law. And then another type of graph that's very useful in order to analyze, for instance, trends are line charts. And for that, I'm going to use a different database, a different data frame. Let me use a COVID one. So here on my database, let me show less. So we have different dates in 2020 with columns for COVID cases for Brazil, India, and in the US. If I want to see, for instance, only Brazil, it's quite easy. And let me. So again, some idea, create a chart object using the data frame. My data frame now is called COVID. And the marking here, it's a line chart. And the encoding, I'm gonna say that I wanna, on the x-axis, of course, I want the date, this date column here. If you wanna analyze trend, if you wanna use a line chart, definitely have to have a time series on the x-axis, and I'm gonna show something that's gonna generate a little error that I have to adjust. In the y-axis, I just say that I want Brazil. Seems more or less right, but quite isn't. And if you see this date here, it's not understanding as an actual date. It seems to be interpreting it as strings. So for the kind of variables that you want to use, in some cases you have to declare what its type, right? And Altair support the 4 classical type of numerical variables. So we could have something like real value numerical variables. So it's called quantitative variables. We could use the Q noting, marking. In a lot of cases, the variable, it is automatically inferred from the system, but in some cases, I have to directly inform. Anyhow, every single time, he's considered one of these 4 type of variables, either quantitative, a continuous number, nominal, which is a category, but without any order, or ordinal, again, a categorical value, but with some order. So nominal would be like, for instance, the courses, like law, economics, and so on. It's a kind of unordered nominal value, right? You can say that economics is before law or something like that. It's only 4 different categories. In ordinal, we could consider, for instance, this grading here, the score, like A, B, D, it's also categories, but there is no order, right? So the A, it's a better score than B, the better score than C, then D, then F, and so on, right? And lastly, we have temporal variables, exactly related to time series, which is the case. And for that, to use this marking here of a T, right? So in order to correct our little graph here, just put a semicolon here and a little T. And now we actually have the number of new cases of COVID throughout the pandemic for Brazil. But yeah, if in case you don't want only Brazil, if want to compare different countries next to each other, probably instead of having data in different columns, we should have the data on what we call metadata. Let me try another data source here, a data frame. Let's have this new table here called COVE, and see that we have the melted version of that data. Still have the date column as a time series, but instead of having one column for each country, we have a column called variable, which determines a country, and then the value, the COVID case number for each country, right? So in this case, it would be very straightforward to present a line chart for every country. And the other way around, in case I want to show only Brazil again, I have to do some filtering. And again, I could definitely do filtering using Pandas data frame directly, something like this. I could say on my COVID data frame, let's filter on the column variable that matches Brazil. So we have only Brazil COVID case. So I can do prior, like even generate a different data frame called like DR and input it to Altair, but I actually don't want to do that. I want Altair to do some filtering capabilities that it offers. So very similar to what we had here. Let me even copy and paste this mark line, and now my data frame is called COVE. The encode is quite similar. It's date with a T. The amount of cases now the column value, right? And I want to do some filtering. So I want to throw here additional information, a transformation actually, transform filter, and it has a specific syntax. Filter. When we want to reference the data frame, it's called by default datum, and we did datum. I want the column variable to be equals to Brazil. And in order to don't have any confusion on quoting, this external quoting you can use double quoting, and the internal ones you can use single quoting. That you will do fine. And yeah, here we have it. Of course, we had the very same result. The fun part now is that I can choose not filtering. Instead of filtering, I can ask to present all countries at once. In case I didn't do the filtering, what they're going to do is they would mix it up. All the cases between US, India, and Brazil going to be a very odd graph, right? Let's get back the filtering. Yeah, sounds interesting. And now let's show each country side by side. I don't have the filtering anymore. And in order to separate the categories for each country, I can use the color definition. I can have a different category, a different color for each country, and keep in mind I have the information about the country on the variable column, right? So here it is. And now I can compare the COVID cases between Brazil, India, and the US, right? That's interesting, right? Well, so moving on, let's start using scatterplot. Scatterplot is very useful to analyze correlation between a variable and another. Let's try another data set, some more grades. So I have these grades here. So we have 3 different exams for students and the final grade. And if I want to see if there is any correlation between the second grade, the grade of the second exam and the third exam, in the sense, if a student went well on the second exam, is expected to be well on the third one, and how that relates, for instance, with exam one, we can do all these correlations. That's very useful, for instance, in order if you want to create a linear regression to predict future grades. But I guess it's a topic for another moment. But anyhow, if you want to do scatter plots, again, same idea. Let me keep copy and pasting, create a chart object, reference the data frame that you want. So I want grades, and now I want to mark point dots. That's the one that is used to scatter plot. And in order to encode, I'll have as an x-axis, I'll have the, let's say, exam2, AP2, and y-axis, I'll have AP3. See, there is any correlation between the third exam and the second exams. Seems the case, right? If you're familiar with linear regression, you could definitely see some trend here. Could create a linear regression on those 2 variables. You could create a trend line that, see that reference, right? Would be helpful for us to try to predict new grades. For instance, never had a student that got an 8 on the second grade, but if you do a little projection here, would expect the student that gets an 8 on the second grade to get like 7.7, something like that, right? But yeah, that anyhow is a scatter plot showing that there is a strong correlation between second grade, second exam, and third exam, right? So someone that went poorly on the second exam, it's very likely that goes also poorly on the third one, and the other way around, the student that went well on the third exam, very likely they would be okay on the third one. Another thing that you can do here is to throw some interactive feature here. You can simply say interactive, and then you can do some little play around. You can do like zooming, moving the graph around, besides usual feature like saving as image and so on, or exporting to Vega, which is a JSON format that can be exported to a JavaScript environment, for instance, to show this kind of graph on HTML and so on. But it can do some interactive movement here, right? Not that big, but interesting enough. Another thing that we're working with correlation, it's actually calculate correlations. Altair don't calculate directly, but it's very simple to calculate. On Python, if I have the data frame grades, I can still call this method core, and I'm going to show the correlation of these grades. I can see, for instance, the correlation between the exam 2 and exam 3, it's very high, close to 1, 0.95. The exam between exam 1 and 2 is not that big, 0.27, and so on. But anyhow, let's save it in a variable called core. And I can see that information visually in a heat map, right? So in order to do so, I'm gonna again transform it in a data frame and reset the index. So for core, I will ask core to reset index. Here it is, and the index now, it's a column. The index itself, it's a column on its own. And then in order to Altair to process this data, similar to what we did with COVID cases, ideally should be on its melted form. You can do the melting right here. We could do something like core melt, and as an identification variable, the fixed variable, it's basically the index. So you can just have to say ID vars it's or r the index, and it's going to generate the melted version of this very same table, right? Let's save it in another variable called CORR, and like take only like 3 first row of it. And here we have it. And now it's pretty much ready to be thrown at a heat map graph on Altair. It's what they call rectangular graphs. So and just make sure that I put the right data frame. It's CORR, and the marking here, the geometry here, it's rectangular, and the encode is gonna be on the x-axis. I want this column index. On the y column, I want the variable column. And lastly, as intensity of correlation. So the dark colors are the ones close to 1. We can have the attribute color associated with this column value, right? Value. So here it is. We have a heat map. It's very nice or easy to analyze this correlation visually. I can see, of course, exam 1 against exam 1 is 100% correlation, the same for exam 2, exam 2, exam 3, exam 3, and so on. But you can see, for instance, that there is a very strong correlation between exam 3 and exam 2, like this little box here, right, and so on. And the caption, the legends are here. So very, very light colors is a weak correlation, and very like dark blue is very strong correlation up to 1. Alrighty, yeah, that's pretty much it. And a couple of last graphs that I want to show. The statistical one of histogram. If you want to see a distribution of a variable, it's interesting enough. We can go back to our original data frame, or you can use this one. You can use this grades one. Yeah, it is. No, let's do better. Let's go back to the original one, DF, right? Let me reload it here, just in case we lost that reference, or at least for you to remember. Right, to remember those guys? Yeah, right. So let's take the distribution for this grade, for instance. It's quite simple. For that histogram, in the end, it's a bar chart of the calculation of frequency. Calculation for frequency sounds like a very sophisticated statistical concept, but only a counting of some categories, right? Or at least some bins for continuous values. But anyhow, so we can have as data source for our chart, the DF, We're gonna use a bar chart for generate histogram. And the marking here of the encoding is quite simple. We say what's the variable that we wanna create the histogram. We're gonna use the grade here. And you can say that y-axis, they wanna do a counting. So you can simply throw the count function here without any additional parameters. It's implicit that you wanna count the grades for some buckets or some buckets, and you have the histogram distribution for this guy. Another very interesting statistical graph is the box plot, right? Again, very similar, very simple. It actually has a proper marking for box plot, proper geometry. So the marking here sort of being bar, it's box plot, and the coding couldn't be simpler. So we won't say that when a box plot for the variable grade. And here it is. I have the box plot, the quartile calculation for the grade. In every single course, it's mixture here, either law, economics, and business administration. If you want to split those guys, it's also possible. We could do something like on the y-axis, I can have a categorical value of the course, the categorical column of the course, and you're going to have 3 different box plots for each type of course. And you can see again that the economics seems very condensed in high grades, but interesting enough, we see that law, it's a very dispersed group. It has very high score, with over 9, close to 10, even better than economics, but at the same time, with very low grades, people with lower than grade 4, right? And if you want to see something even more beautiful here, I can throw some colors, a color for each course. So folks, that's pretty much it I want to show today. We've seen a bunch of different graphs. We have, of course, much more details on Altair, especially if you want to throw additional titles and additional information for X. It's all part of the aesthetics that you can keep adding to the process here. But again, I guess the best value it brings, it's the powerful and beautiful graphs that generate, and a standard format in order to do so, right? It follow always the same pattern, very similar to ggplot2 from R. We simply define the what you usually call geometry. They call it here marking. You define that if it's a mark for a line graph, for a bar chart, for a box plot, whatever. Just make sure that you choose the right graph for your specific analysis, and then you throw the input information for the graph, what ggplot call aesthetics here, it's called the encoding, right? So what your x-axis information and the y-axis. And one last reminder, it's that some summarization don't have to do prior to input it to the graph. It can definitely do for you. You can embed some summarization functions within the encoding, within the graph definition, right? So that's pretty much it. Thank you so much. See you next time.